In this video, I'm going to show you how to create a CA certificate. We're going to be using OpenSSL in order to create that certificate. From that certificate, we're then going to create a machine certificate. This is the one that we apply to our Asterisk PBX, and I'm going to show you how to do all that. We'll then create the settings that we require in order to establish a secure connection to this PBX and have a secure call. I'm then going to show you how to establish a Websocket connection, also using TLS and our secure connection. So, if you're interested in all of this, stick around. Hey guys, thanks for joining. My name is Conrad de Wet and welcome to Innovate Asterisk. That's correct. In this video, I'm going to show you how to generate a CA certificate. This certificate we will then use to sign additional certificates. So the way it works is that a CA certificate is the certificate authority. This is the overall certificate that we use then to sign additional certificates. We can sign many, but in this case we only really need one. We're then going to take that certificate and apply it to the Asterisk PBX, and I'm going to show you how to do that. So first of all, let's go to the desktop to download the Raspbian operating system. So I'm going to choose Raspbian, I'm going to choose Buster Lite, and I'm going to download the zip file over here. I have it, and this is the IMG file that I am going to write to my flash disk. I then choose the image file. My flash disk is now inserted into the PC, and I can click flash. So now it's finished, but you still need to do one thing. So I'm going to close this, and I need to reinsert the flash drive. So give me a sec. The flash drive is now reinserted into the computer. And over here, I need to create an SSH file. One of the easiest ways to write an SSH file into your boot drive is just to use the command line. So here we're going to type sudo nano ssh boot ssh. It gives you this file over here. We don't really need to write anything in it, so I'm just going to exit it, save changes yes to the SSH file, and there you will see it has written this file over here, SSH inside the boot drive. We can now eject the disk and put it into our Raspberry Pi. I now insert the flash disk into the Raspberry Pi with the little gold connections facing towards the PCB, slide it in there firmly and push it with my finger. I make sure that the Raspberry Pi is connected to my network. It should support DHCP. I now take the power cable and push it inside the power cable slot. Light comes on and our Raspberry Pi is now beating. So now we're back at our terminal, and now we can connect to our Raspberry Pi. So I type SSH Pi at Raspberry Pi .local. Okay, now I'm showing you this because I've connected to this machine already, and the computer has already saved the host entry into the .ssh file. If you come across this, then you can do the following. Nano, this file over here, there you can see the Raspberry Pi .local. So I'm going to cut it and save it. Save changes. Now I can connect again, and I say yes. Default password is Raspberry. Okay, so now I'm inside my Raspberry Pi. Now in order to continue, we're going to install a few things. So in order to do that, I need to be in as root. So I'm going to say sudo su, right, and there I am, home Pi. Now apt-get update, That's going to update all the links to the various binary files so that when the system downloads any of the files, it has the correct links. Now I need to install the following applications. Right, so apt-get install is the command, and I'm going to install Asterisk, Samba, NTP, NTP stat. All right, the NTP is the network time protocol. I like to install it just so that the Raspberry Pi can keep a good time. Samba is for our remote file system so that we can connect to it easily by this computer and use things like Visual Studio. Asterisk is, of course, our VoIP application. Type yes and allow it to do its thing. At this point, we're going to choose no. We've installed those applications now. First of all, I just want to test that the date is correct. So I choose date, and there you go. February 11th, and GMT is our time zone. So that's fine. Next, I'm going to configure Samba. In order to do that, I need to add a Samba user, which is the same as our current user. So I'm going to write the following command. Samba pass wd a for add pi, and I'm going to give it the same password, raspberry, and confirm raspberry dot added. So now I have a synchronized user, which is the same as my system user, that's pi. Now I'm going to edit my smb.conf file. I'm going to go there. Sorry, if you missed that, that's etc samba smb.conf. There's the file that we're editing over there. All right, and I'm just going to go right down to the bottom. Some of the printer stuff we don't really need, but for the moment we're just going to ignore that. We want to create ourselves a share, and this is what we do to do that. Paste this at the bottom. All right, so I'm at the bottom of that file, and I'm pasting this. This is our share, Innovate Asterisk share. It's in the path root, which is great. The browsable is yes, write is yes, read only no. You, funny enough, have to specify that twice. Create a mask. The create mask is set to 0755, which means that you get read and write abilities. The guest is okay. Guest okay is no, so essentially we're not logging in as a guest, which again refers back to the read and write abilities. Security is based on user, so that is how we're going to log in, and that is the Pi user, and we're going to force ourselves up into the root account when we do log in, so that we get essentially root read and write access. So I'm now going to exit that, save changes, yes, and the file. Once I've made those changes, I now need to restart the service. So I'm going to type service smbd restart, and that's the restart command. Okay, our service is restarted. That means we can connect to this server. So I'm going to go on a Mac, it's go, connect to server, Raspberry Pi.local, connect. Remember, at this point I log in as Pi, and the password was Raspberry. It then offers me Innovate Asterisk as the share, which is the share that we just created. I click OK to that, and now have access to the full filing system. So at this point, we're going to start using the OpenSSL application. This is the application that we use to create these certificates, and it's a very powerful and quite a well-established application. And I'm going to take you through some of the commands and some of the parameters that we're going to use in order to create our certificate. The first thing we're going to do is we're going to create a certificate authority. The reason why we're creating a certificate authority first is because from that CA, we're going to then create a device certificate. That's the certificate that we typically use when we request a certificate in, say, for example, a web browser or something like that. Now, this is the certificate that is going to reside on the actual Raspberry Pi. It is then going to serve that certificate when you connect as a connection from the outside. So understand that the CA certificate is used to sign and create a certificate, a device certificate. That's the one that sits on this computer, on the Raspberry Pi. We then serve that certificate as part of the initial connection, right? That's when we're connecting with the browser. Okay, it's quite an important thing to understand. The CA certificate is used to create a certificate which is then served as part of your request. Okay, now the reason why we need to go through this is because Google Chrome and more devices are not accepting self-signed certificates. The typical way to do something was to use a self-signed certificate. And a self-signed certificate is similar to this, right? Because we are also self-signing certificates. But we're creating a CA, and we're actually going to become the certificate authority. We're essentially making it up, but in order to make up the certificate, we're creating ourselves as an authority. We're then going to use that CA certificate and put it on any device that is going to connect to our computer. And that is why we're going to have a secure connection. And that is also why why a self-signed certificate is not really secure, because it doesn't require you to take a CA file and put it onto your computer. Right, this will all become clear as we go through it. So let's go to my screen. Here we have OpenSSL. Let's just show you it is installed, version 1.1.1. That's fine. First of all, we're going to need to make some folders for ourselves. So we're going to use the mkdir, and we're just going to put it in home pi ca, right? Then we're going to make another folder for certs, and we're going to make another folder for certificate signing requests, and I'll show you what all that is about later. Okay, so we've made some folders for ourselves. In fact, if we go ls-l, we'll see those 3 folders that we created. First things first, we're making a key. Now, this is the command using OpenSSL to generate an RSA. That's an RSA private key, right? We're going to use triple DES as the encryption algorithm, and we're going to output it to this folder, CCA, innovate asterisk root CA, okay, because that's what we're making. We're making the root CA dot key, and I'm going to use a 4096 length key, right? So there you go. It generates an RSA private key, 4096 bits long, and it just sort of carries on a bit for itself. Right, it is going to ask you to type in a password. Now, this password is very important. Let me take you through some of this. The CA is the certificate that we're going to use to sign other certificates. Remember what I said? The certificate authority is the certificate that we use to sign other certificates. Now, we can create another CA when the current certificate authority expires. And we're going to make a 10-year certificate, but you could make a shorter one. But you must realize that in 10 years' time, or whenever your certificate authority, the actual root CA, whenever it expires, you'll need to make another one. But in order to make another one where the certificate authority can be replaced, we'll need to use the same key in order to generate it. Now, we've just generated a key. So there is our key, right? And it's asking for a password. Now, the reason why it's so important to get the key right is because I can make another CA using this key, but this key never expires. It is the key. If you're going to save one piece of information that is important, this root CA key is the most important. So I'm going to type a password. It's going to ask me to do it twice. Okay, it's now written the password, so I'm going to say cdca, and I'm going to say ls-l. Okay, there is my key. That key, let's have a look at it. Innovate asterisk.key is a RSA private key. So it says a begin RSA private key, end RSA private key. It's kind of like a very, very complicated password, I guess you could say. All right. And that password or that key is what we're going to use to generate a CA. Now remember, I can create more CAs, but as soon as I change my key, everything changes, right? That's the rules. So your key is the one thing. This root CA key is the one thing that cannot change. Now, typically when you go to certificate websites like DigiCerts and things like that, they will ask you for a certificate signing request. You will then give them that, which contains all the information inside it, and they will return you with a certificate. So they are the certificate authority. But in this case, we are the certificate authority. So on the same box that we're making our CA, we're also going to be making the device certificates based on the certificate request. Now, it's not a terribly difficult concept to understand, but we are the CA and we're the provider of the certificates. So just bear that in mind. And the reason why I mention this is because we've broken this down into various different folders. So we're saying CA, certs, and requests. So now at the moment we're working in the CA folder because that's the part of this project that we're completing. We're making a CA. Once we've made a CA, we're then done with making a CA. We can work on making the device certificates from there on. So let's finish up making our certificate, authority certificate. So I'm going to then complete the next line of code, and it's like this. OpenSSL, I'm making a request, a certificate request, using the X509 certificate format essentially. I'm making a new certificate, and this no DES essentially means that I'm not going to use DES encryption or algorithm. The DES essentially is what prompted me for the password previously. But my CA is going to be passwordless. I don't need it to have a password. Remember, the file that I'm creating now, the cert file, is the publicly available certificate. I want essentially anyone to be able to take this file. There is no harm in me dishing out this certificate file to everyone because my key is what is private and what stays behind on this computer or gets locked away in a file somewhere. All right? So the key file is what I handed. And from that key file, remember, you can only generate a certificate from a key. From that key file, I'm then going to create a certificate. All right. Some of the other parameters, SHA-256 is the hashing algorithm, and the days of 3,650, essentially 10 years. Right. This parameter out means that I'm going to output it into this folder. Okay. All understand what that is? Let's hit enter. Okay. Now it's asking me for the password that I used to create this file. Remember, it is a password protected file. Okay. It was used. It was created with a password. So it's saying, please supply me the password you used when you created that CA file. So I'm going to retype it. I hope you remember it. Now it's going to ask me some questions. Now these questions are essentially subject questions. It's a bit of a strange thing over the years. It's sort of evolved into this. But it asks you for various pieces of information about, and this is where you describe various things about, say, your organization or who you are. So remember, we're creating a certificate that is going to describe the information essentially that you're protecting. So I'm going to type GB, and then I'm going to say none for the state. I don't need to say anything about it, and I'm not really even going to worry about the city organization. Well, here I'm going to say innovate asterisk, innovate asterisk, organizational unit name, www.innovate.com. Might as well, maybe a website or something like that. Now, in your server, fully qualified domain name or your name, essentially here, I'm going to describe the certificate. I'm going to say innovate asterisk root CA. Typically in certificate requests you would want to put your server's qualified name here, like www.google.com or whatever it is. But because this is a CA, it's never going to validate the common name against what we type here. I'm just going to further describe the certificate. So I'm going to put innovate asterisk root CA, email address conradjdw@gmail.com. More than welcome to email me. Alright, we're done. ls-l gives me my certificate. That certificate is what we now have generated using that key. I can make another one of those in 10 years' time, but I cannot make another one of these. That key is permanent. The certificate is valid for 10 years. All right. Now that we've created our CA certificate, I'm going to go back and I'm now going to go and create a certificate for this device. Remember, all we did here in this part is create the root CA. Okay? That is the certificate that we're going to use to sign additional certificates. So now we're going to make a config file. The config file is useful. It sets up our certificate generation for version 3. So we're not making it a CA. No, we've just already made it a CA. We've got some key usages and digital signatures, essentially the one that we want, and subject alternate names. So subject alternate names are, well, they're essentially your DNS records. So Raspberry Pi.local, remember, we connect to this computer at raspberrypi.local, right? That's its domain name, okay? So we can have alternate names over here, but there's no alternate names for this computer. So DNS1 is raspberrypi.local. Essentially, another way to use this would be to say DNS.to, let's say we want to say www.raspberrypi.local, right? This is a way for the certificate to be valid for both those entries. You understand that? I could type in www.raspberrypi.local or normal raspberrypi.local. But these are typically used in places like this, right? .com. The .local, remember, is our MDNS system in place. So I'm not going to use that. I'm saying .local. In fact, I only have the one connection. So I'm going to leave that like that. Raspberry Pi.local is the way we're going to connect to this computer, right? Control X, save, yes. CD, CSR. So we're at the certificate generation, signing request generation phase, and there is my OpenSSL version 3 file. That is inside the CSR folder. So first it's CA, then it's a certificate request, and then it's building the certificate. So now I'm going to generate my key. Like we created a key for my CA certificate, we're also going to make a key for my device certificate. This is the certificate that is going to be hosted on this box. right? It's also request, it's also new, it's also 256, it's also with no DES. The output file is my CSR file over here. This is the output file. I'm creating a new key, and it's using the RSA encryption 2048 bits. The key out file is the key out over there. So what we're actually going to generate is two files at this point. A certificate signing request with a new key. Right, again, it's going to ask us for that information. So I'm going to say GB, and I'm going to say some state. Well, yes, some state. You will fill this in correctly. Remember, you want to identify yourself as accurately as possible. If somebody sees this, they can see the information clearly. So just to demonstrate, I'm going to put a little smiley face, and you will see how that transpires. The city is whatever, London, and the company is called My Raspberry Pi. Well, that is true, because essentially this is my Raspberry Pi. The organizational unit or section, I'm going to call this head office, and I'm going to say Raspberry Pi dot local, right? But as you saw earlier on, the version 3 format, this file over here that we generated over here, allows for multiple of these fully qualified domain names. Under email address, I'm just going to leave that empty. Under the extra attributes, you get challenge password, which is none, and additional company name, which is none. So now I have a CSR. ls-l, right? So there's my certificate signing request. So Raspberry Pi is my certificate signing request. This file is my config file, and I'm going to now use that to create an actual certificate. So let's go through some of these settings over here. First of all, I have OpenSSL, which is my application. I'm using X509 as my certificate format, that's correct. And then I have my request in is my CSR file. So I'm supplying it with my certificate signing request. I'm then providing it with a CA, so that's this CA certificate, and I'm providing it with my CA key. That's this file over there. So CA create serial is the next parameter, which is essentially saying that it must create a serial number for the certificate. And now on the output side, I have the following information. Output to the cert, Raspberry Pi.cert, days. In this case, I'm using 365. So 1 year validity. SH8256 is the hashing algorithm that we're going to use. And the extra file, which we put together earlier, is my OpenSSL version 3 config. Now it's going to ask me, you can see it's got some of my subject information over there, remember that. It's going to ask me for my root CA key. Remember that password that you typed in? So I'm going to type it in again. Okay, now I have got, we outputted to certificate file, cd certs. Right, now I have my certificate and the key that goes with it. Again, keys are permanent. You want to keep that here, and you want to be able to provide that certificate. So you want to issue that certificate, because remember, this is the certificate that stays on this computer. The certificate sign-in request and the key are used to create the cert, and they stay on this computer. So that's what stays here. Right, the next thing we're going to do, because we've essentially created our certificate, is we're going to create one more, and I'll show you when we're going to use that. From the cert and the key, that's these two files over here, I'm going to create a PEM. The PEM file format is just as a mixture of the two. It's just added together. So type enter ls minus l over here. Now I have a PEM file. I can show you what the PEM is. Well, first of all, let me show you the other ones. So nano, right, so Raspberry Pi .crt. So this is our certificate, begin certificate, end certificate. As I said, it's SHA-256 hashed data. It's just bytes of data. All right, let's have a look at the key. Begin private key, end private key. So that's our key. All right, and the PEM file you will probably find is just the two mushed together. Begin certificate, begin private key. All right, and there is a place that we're going to use that PEM file. So there's one more thing to do. If I look at my file system, you will notice that my key file, OpenSSL does this by default, will write the file without any read permissions for anybody else, without any permissions for anybody else. So what I'm going to do here is I'm going to use chmod to change the permission. The reason why we need the permission like that is because Asterisk runs as the Asterisk user, and it won't be able to read my key, right? Because only the root can read and write. And now what we've just applied by doing that setting, chmod add plus R to Raspberry Pi key, means that other users on the box can read the key, right? Makes sense. Okay, so now I have completed my task of the certificates. I have created a CA, a certificate authority. I've then, with a key, the key I'm using forever, and I'm keeping that, and my CA certificate is valid for 10 years. I use my key and my certificate to create device certificates. These are the certificates that reside on this box. Remember, I could have created my CA certificate and the key on any computer, and I could have done that part at a separate place. So I have three files that are vitally important to me now. I have three files that are important to me now: the cert, the key, and the PEM, remembering that the PEM is just a combination of the cert and the key. And over here I have the root CA and the root CA key. Okay, the other files, the certificate request files and the version 3, the SSL version 3 config file, I can actually remove at this point. We've created our certificates, but we need to apply them now to Asterisk. And we need to get Asterisk to use these certificates, and I'm going to show you how to do that now. So now I'm going to go back to my filing system, and I'm going to go to etc. Asterisk, and I need the following files. I need HTTP, just move that over there, put that in there, don't need that one, my HTTP, my zip, so zip.conf, I need extensions.conf. Okay, there's a couple of things extra in here. There's an extensions AEL, which I don't need. Delete, and LUA, delete, I don't need. I just need extensions.conf. So I'm going to put that there. zip.conf, http.conf, extensions.conf. Those are your sort of basics ones. Zip and extensions works together, and the http conf is for demonstrating the SSL connection, and also to use WebSockets as a connection. I'm going to demonstrate that in a bit. So take this all out and put my own in. So it actually only needs the following files. So there it is. Under General, which is required, I'm going to essentially say enabled no. I'm going to disable the HTTP serving. What this is referring to is HTTP. And we don't want HTTP serving. We want HTTPS. Okay? TLS enabled is yes. So that enables HTTPS. So you could essentially say HTTPS. Right? It's going to need a bind address and port. And I'm going to give it a bind address of essentially all the any IP address. That's 0000. Now I'm going to give it the port of 4443. I'd give anybody 10 marks for telling me why I can't use 443. Well, the answer to that is that we're running Asterisk as an Asterisk user, and Asterisk doesn't have permission to set up a host on 443. We need to use a port which is greater than 1024. 1024 are all the host ports that are essentially typical or common. And if we try and put our HTTPS serving onto a port under 1024, we're going to get a permission error. Now, it's going to need the certificate files. So it needs the Raspberry Pi cert and the private key. So those are the two files over there. So we save that. Okay. And let's go back to the terminal. So here. And let's do some, I need to restart Asterisk. Service Asterisk status. Let's have a look. It's running. Okay, so restart. Okay. By restarting it, it would have now started to get those settings in. So these settings would now be applied into Asterisk. So in order to see that Asterisk is in fact running with those settings, I'm going to paste that in there. Right, let's look for 4443. There you go. Okay, so right now we can see that Asterisk is running a web service on 4443 over there under the user Asterisk. Great. So that would mean that I can connect to this box. So what are we going to type? HTTPS Raspberry Pi dot local, right? Colon 4443. Who thinks this is going to work? Oops, not secure. So let me explain something here. What Google is saying is that it sees it as a connection, but there is something that it's not happy with. It's going to have a look. It's saying certificate invalid. So I've reached here. Let's have a look. Saying it can see the certificate, it can see the connection, but it's not valid. I'm going to click on this. It says here not secure. I'm going to say certificate invalid. So this is interesting. Hold on. Some of our information is appearing here. I've got Raspberry Pi local. Certificate is not trusted. Not trusted. Okay. So it's saying country, region, state. There you go. This is the information we type. So it's saying that the certificate that we created for ourselves is there. Issuer, GB, Innovate Asterisk. There you go. Common name, root CA, Conrad JDW. So it's got everything here. It just can't trust it. Let's have a look. If I go to inspect and I go to security. Another thing we can find out here is that, so it's seeing the connection as secure, all resources are served securely, but the certificate is invalid. Right, so let me just explain to you what's happening here. We've signed our own certificate, and we've now served the result of our certificate. But our CA, our certificate authority, is not trusted. Right? All browsers, or all computers actually, have got what is called a root CA list. And that root CA list is essentially the certificate authorities that by default they trust. And this list is sort of generated over a number of years of understanding which companies that issue certificates should be trusted or not. But we have the root CA. So let's go and have a look if we can find it. So I can go back to Innovate Asterisk. I can go to Home Pi CA. So I have the CA there. So now we need to install it on our computer, right? So let's go to the desktop, and I have made myself a little temp folder over there. So I'm going to put it over there. Okay, I have now taken my root CA. I hope I didn't move it. Yes, I've copied it. Okay, so it's in both places. Okay, and I'm actually going to install this onto my computer. To do that, quite simple on a Mac, I just double click it. What comes up is the Mac Keychain Access. Now on Windows, we will have the Windows Certificate Manager, but on the Mac, we have the Keychain Access. And inside here already, because we double clicked on it, we have the Innovate Asterisk root CA. So this is the root CA, the file that we generated on the Raspberry Pi. We copied over to the computer. It's now sitting here, but it's not trusted. Double click it. There it is. There's the details. And this is the permission, the trust permission. I want to say always trust. By saying always trust, we're then effectively saying that we do trust the Innovate Asterisk root CA. Okay, I'm just going to close the window which applies the settings, and you're going to need to type in your password in order to do that. Now you will see that the certificate has got a little blue plus on it. It says this certificate is marked as trust for all users. Right, we're now done with Keychain Access, so I can move that out the way. I'm done with this. I can go back here. Now I simply refresh and everything comes out correctly. Right, so there you go. Certificate is valid. Let's have a look at our certificate. So we have the root CA, details of the root CA over there, which was used to create another certificate, which is our device certificate, Raspberry Pi.local, and this certificate is valid. Subject information over there, issuer information over here. So you can see that there is a chain inside the certificates. This is the issuer certificate that we trust because we installed that on our computer. You'll notice that this little step didn't exist before. The server only serves this certificate. When a connection is established, it only serves this certificate. It's always up to you as the receiving side to have a certificate in your certificate store matching the signing of this certificate. Okay, so this certificate here, issuer, is what you keep, what you have, what you store on your computer. That's this one over here. Right? Understand that? Okay, so now we've created a secure connection to the Asterisk server. Now, we now need to create a secure call. In order to do that, we need to start setting up the Asterisk in order to have an extension. And once we've got an extension, we can do a test call, and then I'm going to enable the encryption and the secure settings. Let's go back to Visual Studio. Now we're going to go to our sip.conf and we're going to search for TLS enable, right? And here it is over here. So just above, I'm going to create myself a little bit of space, and I'm going to see that's commented out. TLS enabled equals yes. So now we're enabling TLS. TLS bind address and port. So 0000, port 5067. Remember, it's above 1024. HTTP has something similar. Bind address. SIP has another bind address. Okay. Then it's going to ask for the TLS cert file. And remember, the PEM file was made up from those two files, the cert and the key, right? And it's asking for a combined certificate file. That's why we made the PEM file. So essentially, TLS cert file is a combined file because the next thing it asks for is the CA file, right? It's saying, what is your CA? And this we can give them CA root.cert, and that's the file that we give them. So TLS requires a combined cert and key for the PEM file over there and the CA root over there. So now I've created my TLS connection, so I can save that file. So now I can go back into my command line and I can restart Asterisk, go back to my netstat, and I'm looking for 5061, which will be, yeah, there you go, Asterisk 5061 there. And that means that Asterisk is now listening on TCP port 5061 for those connections that come through for TLS. So in order to create an extension that accepts TLS connections, I'm now going to go back to my sip.conf, and I'm going down to the bottom of that file, create a bit of a section for myself, and I'm going to add my user. So if you have been following this channel and this playlist, actually you'll know how to create a user. I've created a user of type friend, making and receiving calls. My context is from phones, okay? My secret is 1234, and my host is dynamic, right? Because we're going to register. DTMF is just a default setting. I'm going to disallow all codecs except for my ULAW codec, and encryption is not going to be on, so I'm commenting that out. So encryption is off by default, but my transport is UDP and TLS. So now these two are sort of in conflict with each other. If encryption is off, I can use UDP. If encryption is on, then I'll want to use TLS. And now this is something that's quite important to understand. And some phone manufacturers actually get it wrong, and then I'll demonstrate that to you in a second. So there isn't much point in creating a secure call if your SIP signaling is not done in TLS. Now some applications and some phones are aware of this, and they will not allow you to create an encrypted call. That's the actual UDP packets of data, the actual sound packets encrypted while the signaling is not encrypted. Now the Yelling phone, which I'm going to demonstrate to you in a second, can create a secure call with unsecure signaling. But typically you would want your signaling to be done in TLS while your data is encrypted. So by going here and saying encryption on will mean that your RTP packets, right, RTP only only your RTP packets are going to be encrypted, but the configuration and setup might have been done over UDP or TLS. So something to be aware that if you truly want to have a secure call, your encryption, yes, must be on, but you must be using TLS and you cannot be using UDP. But I'm going to just demonstrate this for a second just to show you that I've got my phone registered. Okay, and I'm going to say encryption is off. I'm going to allow for UDP connection. So I'm going to save that. I'm then going to go back to my extensions.conf, and if you can remember, this file is full of unnecessary information. So I'm going to take it all and clear it away, and I'm going to make a very brief dial plan, very brief, and put that in there. Nothing under general. From phones, which is that context that we use over here, from phones is going to be my context. If I dial any number, answer it, wait 1 second, and play music on hold. It's just for demonstration purposes. So there you go. So I have a dial plan, I have a SIP with a user, and it's allowed to use UDP and TLS. Okay, and I'm now going to show you how we can register under UDP. Okay, now that I've made these changes, I just need to go back to my terminal. Restart Asterisk. So if I take you to a web browser, 192.168.88.15, that's my Yearling phone. Admin, default password, username. Once I log in, I'm going to go over to accounts, my second account over here. I'm just going to make another account. Label test, let's call this Raspberry Pi, display name, test, register name, well actually it's user1, register name user1 no space, username user1, password was 1234, right. So first of all, 192.168.88.28. I'm going to log in as UDP. So I'm going to, I need to enable it. Enabled, confirm, operation complete, registered, right? So where's my background here? SIP show peers. Okay, and subshow peer user1. There you go. So I'm registered on my Yearling. Alright, I've switched over to my desktop phone now. And sorry, there's a bit of a glare, but I'm going to make a test call. 2, 3. And you'll see that I can make a call. No problems there. So let's end that. Now I'm going to take you over to the phone settings, and under advanced on the side over here you will go down to Rtp Encryption. So encryption can be on compulsory. So what happens now is that we haven't connected over a TLS connection, right? But we have got encryption on. So now, if I show you what a call looks like now, 1, 2, 3, you'll see that there's a little padlock over there. So what that's indicating is that this call, the RTP packets, are encrypted, but it's not connecting in TLS. Okay, so I'm going to go back to my screen here, Visual Studio, and I'm going to say in sip.conf, I'm going to say first of all encryption is yes. Remember, this is when this device makes an outbound call. Essentially, the previous example was the device making the call. I'm going to take off UDP and leave TLS on. So I've got encryption on and TLS. Right, saving that and applying it. So I'm going to say and reload. Okay, it now reloads it, and I can say show peer user 1, and I only have TLS. Now I can say under my browser settings 5061 TLS. Confirm. Okay, operation completed. Yeah, this is interesting. Now it says register failed. So now I'm using TLS. It's the correct IP address, and I've got port 5061 in there. So what's going on? Because it doesn't really say anything. It just says register failed. But I'm going to tell you what the problem is. So under security, we've got trust certificates, and we've got nothing here. Now it has built-in set of trust certificates that you can get off the internet to show you what certificates it will accept. And you see the setting here, only accept trust certificates. That means it's only going to accept certificates where the CA is installed in this phone. So let's go to browse, and let's go to temp, and let's choose Innovate Asterisk and upload. So what's happened now is I've uploaded my own CA. You see there? Right? The Innovate Asterisk CA. I'm now going to go back to my account page, choose account 2, register failed, confirm, operation, and registered. Alright, did you see that? So if I use TLS, it does check the certificate. I needed to go to security, to service certificates, sorry, trust certificates. I needed to install my CA, then going back to account, choosing account 1, I now have a secure connection. Alright, it is registered. And if I make a call, I now am making a completely secure call. Right? This is not just the RTP packets which are secure. This is the actual connection. The SIP signaling is handled with TLS, and this is what the outcome is. A secure call. It's got the padlock over there, and the media is encrypted as well. Okay, so we created a CA certificate. We then created a device or client certificate. That certificate was installed in the Asterisk box. Okay, we mapped up all the settings. We have a secure connection from a device or a telephone. And now I want to show you just one more thing. In order to do WebRTC, you have to create a secure connection, right? The difference between normal Asterisk, UDP, and SIP is that SIP can operate over UDP without any problems. You can upgrade it essentially to TLS. But when you work with WebSockets, there isn't such an option. They've disabled it from a browser perspective. So what I'm going to show you is how to establish a secure WebSocket connection to our Asterisk box. There is in fact a HTTP status page which shows you that it is operational, and then there is another page which is web service, right? So on /WS we connect to the Asterisk Web Socket environment. It's asking you to upgrade, right? Because a WebSocket requires an upgrade header. Okay, so I need a simple little page that I can use in order to connect to Asterisk and demonstrate a call. In order to create a SIP extension that works over WebSockets, we need to make quite a lot of changes to the SIP settings. So let's go and have a look now and see the SIP settings that we need in order to create a WebSocket extension. So I've gone back here and I'm going to go back into Visual Studio Code. And I'm going to make another user in here. All right. I'm going to make 2 users. So let me take all the settings and pop them in, and then we're going to go through some of them. So it starts off much the same. Type is friend, phones, secret 1234, host is dynamic. Yes, DTMF. We all know this. Allow ULAW encryption is yes. So in order to do a WebSocket extension, we need extension to be yes. We need our transport to be on WebSocket. Now the extra S refers to secure. So WebSocket secure, essentially, if you want to say it that way. AVPF is yes. So these are AV audiovisual. These are header information in the SIP invite. Force AVP is yes. ICE support is yes. It does require an ICE exchange in order for you to establish the IP addressing. Now, we're working in a local environment, local IP to local IP address. So this ICE resolution will be rather straightforward because they're directly connectable. Video support is yes. I've just added that in just in case. RTCP MUX. So what that's going to do is it's typically RTP is established on 2 different ports, and the RTCP report comes in every 1 second, every few seconds by default, and that comes in on a different port. So if your media is happening on port, say 5000, your RTCP report will come in on 5001. But this RTCP MUX means that the report and the normal data will just travel on the same port. So it only consumes 1 port for every voice channel. It's a bit better port utilization, but it doesn't really mean anything other than that. You do need to have that setting in. Okay, now we've got the encryption stuff. DTLS enable is yes. Verify by the fingerprint. Our file is to our PEM file. We'll start to pick up some of a pattern here, and our CA file is over here, and then under the DTLS setup you want ACPass as the parameter over there. I'm going to save that now, right? Go back to Asterisk and reload Asterisk. So where's our terminal? Here, and I can just say reload, just pop that inside there. So I'm going to go to my little demonstration page. So this code is something that I've been working on. It's not complete. What it will do is it'll give you an idea as to how these WebSockets operate. So this is the WebSocket stream over here. You can see I choose WebSocket, and it's got a little bit of information in here, subscribe information that we don't need. Here's your register, and I'm going to choose on a user, and I'm going to just dial that user just so that I can demonstrate that it's working. There you go. Music on hold over WebSockets. I'm going to show you later on in other videos a little bit more about this browser phone application, but for now that should have just demonstrated for you how you can in fact create a WebSocket connection. There are other WebSocket libraries that you can use. One of them is SIP.js. So SIP.js is a WebRTC library. It's a development library. So if I go to the API over here, you will see how to establish a connection. You will need to create a user agent, and from that user agent you can connect to Asterisk on WebSockets. All right, so hopefully you've enjoyed that video and you are able to create a secure telephone call. well, that's all we've got time for. But thank you very much for watching. And as per normal, feel free to subscribe if you haven't already. Feel free to like or dislike. And of course, comments are more than welcome. I'll try to reply as soon as I can. And if there is something specific you want a video on, feel free to contact me. You can even email me, conradjdw@gmail.com. Otherwise, until next time, cheerio.